Here in this chapter, we are solving a question that appeared in NEET 2025 from the concept of dual nature of radiation and matter. It's basing on photoelectric effect. Let's have a look at the problem. Which of the following options represents variation of photoelectric current with the property of the light as shown, right? If you see little closely, the first graph says you increase the intensity of the light, photoelectric current increases, right? Let's understand what's the meaning of that. When you increase the intensity of light, actually, it consists of more and more number of photons. Each photon is having a energy h nu. It will go and give it to the electron residing in the metal surface and make it release from the metal surface. So if intensity increases, more photons are available until threshold frequency, until threshold current, of course. Each photon releases an electron, thus as number of electrons increases, current also increases. So this graph is correct. Option A is fine, correct, right? Let's have a look at the second option. Option B. You increase the intensity of light, it says the photoelectric current is flat, which is wrong. As I told just now, as intensity increases, more number of photons are available. Each photon releases electron from the metal surface, so current has to increase like the first graph. So the second graph is wrong. Now the third option. Look at the third option that we have. You increase the frequency of light, photoelectric current increases. So here you need to understand how does that frequency works. Each electron is associated with the metal surface with a minimum energy that is holding that electron with that metal surface. That is called work function. Work function. Work function is h nu naught, where h is a Planck's constant. Nu naught is a minimum frequency called threshold frequency. Means if the incident frequency is less than threshold frequency, the energy of the photon is not sufficient to release the electron from the metal surface, and hence no photoelectric effect happens. If nu is greater than nu naught, photoelectric effect comes. But how many electrons comes out doesn't depends on the frequency. Frequency only decides whether the electron ejects or not. Rather, it depends on photons, right? So even if the frequency of the light increases, photoelectric current is not going to increase. It's going to remain flat. It's independent of frequency of the light. Rather, it depends on intensity of the light. And look at the fourth option. With the frequency of the light, photoelectric current is starting from a point and increasing, right? So this looks like a tempting answer basing on the graphs that you have learned. This minimum frequency is called threshold frequency. You have seen this kind of a graph in textbook, but be careful. What you have seen on the y-axis is not a photoelectric current. Rather it is a potential, right? It is a stopping potential. It's the reverse potential applied, so that you increase the frequency of the light, stopping potential increases. It's not the photoelectric current. So for the given photoelectric current, that is also wrong. So the best possible answer that we have is option A. That's the right answer for the problem. It is a very basic concept basing on the very basic concepts and basic rules of photoelectric effect and Einstein's photoelectric equation. That's it. And thank you for watching.